Welcome to another TCP/IP Basics course, and this time we're going to talk about the OSI model. OSI stands for Open System Interconnection, and originally developed by the Department of Defense. They had much less layers in theirs. They only had 4 layers, but nowadays we use the 7-layer approach. And you can see it's split between the upper layer and the transport service. So we're going to talk about each of these layers. There are 7 total, as I mentioned, and the data travels between the devices. Starts at the application layer, moves all the way down to the physical, then it connects to the other computer, and whichever computer is trying to connect to it for say, an application or for some data, and then it starts the process from the bottom up. So rather than, as the sending computer did, from the top down, when it gets to the receiving computer, it goes from the physical all the way back up to the application layers. Each layer has a job to do. Let's talk about what each layer does. Let's start with layer 1. At the very bottom, it's the physical layer. And that includes the cables, the network card, and basically the connectivity from the computer. Now, if you're using wireless, then of course it's the wireless card. It also includes what's called a loopback test. So if you've ever seen an IP address of 127.0.0.1, that's basically a loopback test, and it's an IP address that tests to make sure that the physical part of your connectivity is working properly. And we have layer 2. It's the data link, and it's split into 2 different parts. The first part is the Ethernet MAC address, and the second part are frames. So we're going to talk about frames more in detail in an upcoming video, but let's just talk about the MAC address for now. So this is the burned-in media access control, that's what MAC stands for, address that's on the network card. And you cannot change that address once it's burned into the card. However, there is software that allows you to spoof that address if you needed to do that. And typically we see this on switching and bridges. So bridges we don't use so much anymore, but bridges basically does what switches do, and that is it sends data back and forth to devices that are on the same network. So if you're on a 192.168.1 network, then you'll connect to other computers on that same network using switches. If you wanted to connect to a different network, you would use a router, which we're going to talk about at layer 3. Now we're at layer 3, and that is the network layer. It routes between different networks. So just as switches sent data back and forth on the same network, routers send data back and forth between differing networks. IP addresses sit at the network layer. So TCP and UDP may sit at the layer 4, but the IP addresses themselves, the IP portion of a TCP IP address, sits at the network layer. And we talked a lot about IP addressing in previous videos. Layer 3 switches do pretty much the same thing that routers do. It allows us to send data back and forth between differing networks. But the switches, in this particular case, they have a lot more ports on them, of course. Usually routers just have 1 or 2 ports on them, and they connect into a switch. So they came up with a layer 3 switch, which does both routing and switching all in one device. And if you get what's called an inter-VLAN switch, then it allows you to route between the different VLANs all on the same switch. Now, those switches tend to cost a little bit more, but they can definitely save you from having to also configure a router as well. Let's talk about layer 4, transport. This is where TCP and UDP sit, as well as other protocols that sit on top of IP. Another example might be GRE, for instance. So as I said, it runs on top of IP. So that's why when you see a TCP/IP, it's literally sitting on top of the network layer IP address. And TCP and UDP, they use ports. 65,535 for each of them. Now, the other things that sit on top of IP addressing aren't necessarily using that many ports. For instance, GRE just uses 1 port, and other protocols use other amounts. But TCP and UDP are the most popular protocols that sit on top of IP, which is why we talk about them the most. Let's talk about layer 5. This is the session layer, and it is all about communication flow. It starts the communication, it ends the communication, and it maintains the communication. So any type of a session that happens between your computer and, say, a website, or, say, your email and sending it to a mail server. It's all using the session layer, layer 5, to start, maintain, and end that connectivity. So it's obviously a very important type of layer. It sits at the upper layer of the OSI model. It also has to do with what's called half and full duplex connectivity. So half duplex is basically one-way connectivity. Full duplex is both directions of connectivity. So half duplex can be extremely slow, and that's what we used to use a long time ago. So by default, everything is set to full duplex nowadays, but if you end up connecting to an older device, it may be at half duplex, and the session layer maintains that type of connectivity. And it's also in charge of tunneling. So if you have a VPN tunnel, for instance, the encryption does not sit at this particular layer, but the tunneling itself does. This is where it keeps it separate and secure from other networks. Now we'll talk about layer 6, the presentation layer. It's in charge of a couple of things: keyboard characters and encryption. So we were talking about the tunneling from the previous layer, layer 5. Layer 6, the presentation, actually handles the encryption portion of things, and it also handles encryption of file and folder encryption. So if you use BitLocker, if you use file and folder encryption in Windows, if you use any type of encryption, then it has to do with the presentation layer. Now, keyboard characters has to do with different languages. So if you have a US keyboard, maybe a UK keyboard, maybe a Japanese keyboard, all those different characters are handled by the presentation layer. So if you're having a problem with those devices, it could be the presentation layer. How do you troubleshoot it? Well, you can't. It's not going to be, there's not going to be a button for the presentation layer or any of these other layers. You just need to know where these layers, sort of where they fit when sending data. It's not that you can reach out and grab any of the OSI layers. This is all more theoretical rather than physically being able to get your hands on them. Now we'll talk about layer 7, application. So what sits at the application? Well, everything that runs a program. So if you're running Microsoft Word, if you're running, any type of program, then it's running at the application layer. If you're running a web browser, that's an application. So it runs at the application layer. So any type of application is going to run at this. Now, it doesn't mean that it uses only the application layer. Let's say you're running a Telnet program. Well, a Telnet program, of course, is at the application layer, but it's sending data at the transport and network layer, at the TCP over IP layer as well. But the application itself is running at layer 7. So as I mentioned, Word, Excel, web browsers, they all run there. So just to recap, we've got the 7 layers of the OSI model. Data travels between the devices from 7 down to 1 and 1 back up to 7. Each layer has an important job to do. The data from each of the 7 layers can be visually seen by using a protocol analyzer device or program. An easy-to-use one could be Wireshark or Network Monitor, and that is freely available. Being able to see the packets broken down into each of their layers can help us identify which layers may be causing problems so we can pinpoint our troubleshooting efforts. In an upcoming video, we'll demonstrate using Wireshark so you can see the different layers and how they operate using this Wireshark program.